Hi there, this video is a follow-up for the Moteino introduction video where I claimed that it was really low power. And what I did was I programmed my Moteino here with a low power sketch, which just blinks the LED that's on board. And hopefully you can see that it's quite visible even with lights on, and especially with lights off. So that was just meant to simulate reading from a low power sensor. So I'm blinking the LED for a couple milliseconds and then going to sleep for the rest of 1 second, and then waking up again, blinking the LED, going back to sleep, and so on. So the circuit is feeding from this 12 CR1225 coin cell battery from sparkfun.com. It's really tiny, and actually here it is for scale. Here's a penny, and here's a battery, and then here's a CR2032 in comparison with it. So it's rated at 48 milliamp hours, and it's about 3.2 volts when it's fully charged. So it's also running through my Fluke multimeter, and I have it on the microamp DC range right now, and it's showing about 34 microamps, and you can see it's spiking when the LED is blinking. So what I'm going to do is just going to turn the min-max feature on, and that's just going to take a while to record the min, max, and average. So you could see how the max is currently at 422 microamps. The min is at 34 microamps, and the average is still kind of RMSing towards about 57 microamps. So this is quite low power actually. It's 57 microamps on average. Of course it'll spike to 423 when it's blinking, and then for most of the rest of the time when it's sleeping it's just going to be very low. So the battery is rated at 48 milliamp hours, like I said, and if you divide that by 0.06 milliamps, you'll get a figure around 800 hours, which is about 33 days. So I guess that's pretty decent for a battery this small. So yeah, that's just to prove, I guess, that it's really low power. Now of course we could hook this up to a AAA battery pack, and that'll be a lot longer lasting if you have a low power sketch. And here's the same circuit again, except this time instead of blinking the LED, I'm transmitting a message with the RFM12B transceiver every second, and it's powered by the same CR1225 coin cell. And here's the messages coming in. There's some other data, but all these test messages are coming from this coin cell powered Moteino. And it's going through my Fluke, which is in the milliamp DC range, and I already had it set up to capture the min and max, and you can see the max peaks at about 4.2 milliamps. You could see how it's transmitting every second or so, and the min is about 50 microamps. The average is about 0.3, which if you divide the 48 milliamp hours rating of the battery by 0.3 milliamps, you get about 160 hours, which is about 6.6 days, which is not too bad for this tiny battery to operate a node which is transmitting a sensor reading every second. Not too bad, I think. And finally I decided to make a change, and instead of transmitting every second, I'm now transmitting every 8 seconds. And here are the results. The average is about 70 microamps, The max is the familiar 4.18, so over 4 milliamps when it's transmitting. The minimum is about 30 microamps. So an average of 70 microamps transmitting at once per 8 seconds will give you about 685 hours of runtime from this tiny cell, which is about 28 days. So again, not too bad. If you have a sensor, like a temperature sensor, you're probably not going to need to report it every second, or not even every 8 seconds, but more likely something like every minute. So you can probably figure out that that'll give you a lot longer runtime from this tiny cell.